Hey guys, we're going to do homework 3-3, multiple choice, and I just want to point something out. So when I first spoke to the textbook company and I printed this homework, these were supposed to be questions in chapter 3, but they're not. They're in chapter 12. But again, this is because of the CED. They want us now teaching this now. So it's really important that I teach it in the order that they want me to. So anyway, you are going to do these questions, but notice 81 is 33 in the textbook in chapter 12. And so I've given the same amount of problems. They just thought they were going to move them in the book, and then they ended up not moving it. So, okay. So here are the questions, and the multiple choice ones are, let's see here. So it says, suppose that the relationship between a response variable y and an explanatory is modeled by this. So I'm just doing this. And notice that x is in the exponent. Okay. So I'm just thinking, thinking in my brain, thinking back over my notes, and we had written exponential, we would plot log y versus x in order to look at that. And so if I look in my notes, and I can actually take a picture of my notes and just kind of show you, this is right out of my notes, right? So kind of like what I do in class, it's like, oh yeah, that was what we were doing, right? And so if I zoom in on these functions here, I notice that if the x is in the exponent, that's exponential. And I notice that if it's exponential, then I need to plot log y versus x. And so then I look for that as my answer, right? And so that is how we got C. So that just goes right out of our notes. Okay, so let's look at the next one. Some high school physics students dropped a ball and measured the distance fallen in centimeters at various times in seconds after it's released. If you studied physics, you probably know that the theoretical relationship between the variables is distance is equal to 490 time squared. So this is basically saying I can predict the distance 490 time, which is x, squared. So a little 2 makes a u, that's quadratic. Notice that x is not in the exponent. It's x to the power of something, x to the power of 2. So if I look back here, my power function, then that's what I'm thinking, log y versus log x. So let's take a look here. Yeah, we would do log y versus log x. Maybe based on our notes, which of the following scatter plots would not approximately follow a straight line? So if we think about this one would, that follows our notes. We also know that anytime I say log, I could also take the natural log, so this would also be the case. I could have also written that here under power, natural log versus natural log. Okay, so this one would be straight. A plot of distance versus time squared. Let's look at these two. We think that this one would also then be straight, right? So we really just have to look at these two. Okay. So now let's see. In order to make it look like that, I would need to take the square root of both sides to get rid of this little 2. So if I think about it, I could take the square root of everything on the left and everything on the right. So then that would give me x. and the square root of y, or distance, right? So then this one would actually be okay too. That's kind of what we have here, square root of distance versus time by itself. So the only one that would not be true linear would be that one. Okay, that was kind of an interesting question. All right. Now, 95. This would have been 53 in chapter 12. So let's take a look. It says, students in Mr. Hartford's class dropped a kickball beneath a motion detector. The detector recorded the height of the ball as it bounced up and down several times. Here's the computer output from a linear regression model. And it is the transformed data of the log of height. So the log of height versus bounce number. So remember, this is a plus bx. That's what x is. This is a, our constant. So we had to put it in this formula, a plus bx. And this is y hat. So y hat is what we're trying to predict. And a, it looks like this. B happens to be negative. So our slope is negative. There's a negative association. And then x is bounce. So what are we trying to predict? Well, this is saying the output is actually, we're trying to predict height, but this is telling us that our output is log of height. So we got log of height, which will help us then predict the height. So it is log of height. Okay. Predict the highest point the ball reaches on its 7th bounce. So we are going to plug in 7 here. And this is similar to what we did in class, and we actually know we're going to come close. We're not going to actually solve for predicted height. We're going to solve for log of height. All right, so let's practice this one over here to the side. So I have log of height is equal to 0.45 minus 0.117 times 7. That's my bounce. So let's do a little calculating. All right, so I get negative 0. Now, that's not my answer. That's the log of my answer. All right, so to do the inverse to both sides, the inverse of log is to take it to the power of 10. So I'm going to take that number to the power of 10. Cool. And when I do that, I get predicted height is 10 to the power of negative 0.362, which is 0.43. And that's my answer. Sweet, right? Okay, last one, and we'll call it a day. A scatter plot of y versus x shows a positive nonlinear association. Okay, so it's positive, it's going up or something, but it's just not straight. So it's bending somehow, not linear. Two different transformations are attempted to try to linearize the association, using the logarithm of the y values and using the square root of the y values. Two least squared regression lines are calculated, one that used x to predict log of y and the other that used x to predict the square root of y. Which of the following would be the best reason to prefer the least squared regression line that uses x to predict log of y? first it says, and also let's think about this. Why would we use this other one? Well, if the value of R is smaller, no. We would use it if R is bigger. Standard deviation of the residual is smaller. Well, notice when we're comparing, you have to be careful because like if you took the square root of a number, so the standard deviation of the residual is like written in a different form now. So you got to be careful there. The slope is greater. We don't really care if the slope is greater. So that's, right, that's just my line of best fit. I'm just want a prediction model. So this is the reason to prefer it is if we saw that one of the graphs had more random scattered, that's a reason. And then normal, we haven't been talking about that. So that's pretty much what we did today in the car pullback example is we picked the one that had more random scatter than any other and that had the highest R. That is exactly what we did. So that's why we picked D. Thanks for joining us, guys.